Hello, Math 141. So we're supposed to find the polynomial of degree 4. And the given zeros are 3 plus 2i and 4 with multiplicity 2. So first of all, what is this 3 plus 2i tells me? I know that complex roots come in pairs. If a 0 of 3 plus 2i is given, then I know that 3 minus 2i is also a 0. 3, its conjugate, which is 3 minus the conjugate of 3 plus 2i, which is 3 minus 2i, is also a 0. And how about this part? How about it's the problem saying the 0, 4 with multiplicity of 2. That means that x equals 4 and x equals to 4. It's one of those points that the graph hits the x-axis at 4 and it bounces back. So I can write this as f of x equals to, let's start with the real root, which is x minus 4. If x equals 4 is a root, x minus 4 is a factor. All I have to do is just solve here and say subtract x from 4 from both sides, so x minus 4 equals 0. So x minus 4 is a factor, and so I have two of those, x minus 4, x minus 4, because the problem is telling me that multiplicity 2. All right, so what does this give me? If I say x equals to that, then I have let me do it here. If I have x equals 3 plus 2i, then if I subtract 3 and 2i, I get x minus 3 minus 2i equals 0. So x minus 3 minus 2i is a factor. And how about this one right here? How about this one right here? If I say x equals to 3 minus 2i and subtract 3 minus 2i from both sides, I'd get x minus 3 plus 2i equals 0. So my fourth factor is going to be x minus 3 plus 2i. And that's what, this is the part that most, a very common mistake happens here, that students write this here as x minus 3 minus 2i, then here they write x plus 3 plus 2i, and that would be a mistake. That's why showing, going through this step, I think at least in the beginning is necessary, so you won't make a mistake. Now all I have to do is just multiply all these parts. So f of x equals x minus 4 times x minus 4 is easy. It's x to the second minus 8x plus 16. To multiply this part, I'm going to make it easy for myself, and I'm going to group this and this. Notice now, if you look at that, something minus 2i and something plus 2i, now it just reminds me of difference of two scores. So if I do my multiplication now, I'm going to have, let me show it this way, that this times this gives me x minus 3 to the second, and this times this cancels this times this, so I don't have to worry about that. And minus 2i times plus 2i gives me minus 4i to the second. So f of x equals x to the second minus 8x plus 16 times x minus 3 to the second gives me x to the second minus 6x plus 9. I squared is -1. -1 times -4 is +4. I'm going to continue on the next page. F of x equals x to the second minus 8x plus 16 times x to the second minus 6x plus 13. Notice that in previous page, 4 and 9 gives me 13. Okay. So now that equals to x squared times x squared is x to the fourth minus 6x cubed plus 13x to the second minus 8x cubed plus 48x to the second minus 104x plus 16x to the second. Then I have minus 96x plus 13 times 16. I believe 208. Okay. Now let's clean this up. F of x equals. I only have one x to the fourth. Now x cubed, I have it in here. I have it in here. That gives me minus 14. Yep, minus 14x cubed. Now x to the second, I have 13 of them here, 48 of them here, 16 of them here. So that's 50, yeah, 77 plus 77 x to the second. And I have, how many x's do I have? I have minus 104 minus 96 gives me minus 200x plus 208. So this is a polynomial of degree 4 that has the roots of 4 multiplicity of 2 and the complex roots of 3 plus 2i and 3 minus 2i. Thanks.